Hello, smart mathematicians. Let's continue with our lesson on the counting principle. We're going to look at rule 3. Right, remember what we did in the previous part of our lesson. We talked about rule 2, and then we had two examples where we had the word solvent, and then we said that with the word solvent, how many different arrangements can we make? It was 7 factorial because we had 7 spaces. Okay, because the word solvent has 7 letters, and then we have 7 choices. And then we had also an example of the 5 public speakers sitting on 5 chairs. So it was 5 choices and 5 spaces, isn't it? Right, now let's look at this situation here. A security pin requires 4 digits. Okay, but the digits are coming from 10 choices from 0 to 9. Remember, from 0 to 9 is 10 digits, isn't it? So these 4 digits must come from 10 choices. So how many different pins can be made if the digits may not be repeated? You see that? So the number of choices and the number of spaces that we have are different. Like this pin here, we need what? We need 4 numbers. We're choosing from 10. So how do we calculate this? Okay, so the first digit, we have how many choices? We have 10 choices. If we have our first digit, then the second digit, we have how many choices? 9. We have 2 now. The third digit, we have how many choices? We have 8 choices. And then the last one, we have what? We have 7 choices. Do you see that? And then how many different pins can we have here? We can have 10 times 9 times 8 times 7, which is 5040. Right. Now we want to bring in the factorial notation to this. Okay. We can bring in factorial notation to this. How do we do that? If you check, this is just the same as this. You see that? Okay, because this red part, we can just say this divided by this, and then we just remain with that. You see that? But we have brought in factorial what? Notation, because the top part, if you check, that is 10 factorial. And then the bottom part is what? Is 6 factorial. You see that? Okay, but these two things are just the same. This and this is just one thing. Here, we're just bringing in what? The factorial notation. Okay, right. And then, so now we're saying this is 10 factorial divided by 6 factorial, which is still 5040. You can use your calculator and see that. Okay, right. But now, if you check again, this denominator, okay, 6, how can we get this 6? Actually, if you check here, there are 4 positions. If you check, which is represented by R, and then to be filled by 10 choices, which is represented by N. And then if you say choices minus the positions, we're getting our 6. Do you see that? So N minus R will give us what? That denominator. So actually, rule 3 says, if R positions are to be filled from N different choices, the number of possible arrangements are what? N factorial divided by n minus r factorial. Like here we had our n, which is 10, and then r, which is 4. You see that? Okay, so we can use this. This is our rule number 3. If r positions have to be filled from n different choices, the number of possible arrangements are n factorial divided by n minus r factorial. You see that? It makes it very, very easy when we bring in what? The factorial notation. Okay? Let's just do an example. 15 athletes are hoping to get the first 3 prizes. Okay? 15 choices, right? Which is gold, silver, bronze, which is 3 positions or 3 spaces. In how many different ways can the first 3 positions be taken? You see that? What is our n here? Is 15. What is our r here? Is 3. So how many different ways can the first 3 positions be taken? We say 15 factorial, which is n factorial, divided by 15 minus 3 factorial, isn't it? Which is like this. Okay? and then we get that it is 2,730 ways. Remember rule number 3. N factorial divided by n minus r factorial. Okay, that is rule number 3 there.